Hello YouTube, this is Scott Grammer and I am the Old Audio Guy, and what you're looking at is an amplifier that has been brought in for me to completely rebuild from the ground up. This is a very early version of the Phase Linear Model 700, which sadly earned the nickname Flame Linear, and we're going to talk about possibly why that is here in a few minutes. Anyway, if you notice, this one looks a little different than some of the ones you've seen before. And that's because, as I say, it's one of the very first ones. Here's a close-up of the nameplate, and then I'll show you the serial number on the back. Notice at the bottom of this plate, the power input rating is 2,500 watts maximum. I believe they had to change that later because with that much of a power rating, they couldn't get a UL listing. It seems to me they had to change that to a lower number in order to get the UL listing, but I'm not 100% sure about that. So here is a picture of the rear of the amplifier showing the output transistors and the driver transistors. The bottom 4 transistors in the heatsink array that you see are the drivers, and the other 20 are the output transistors. This amplifier was, I believe, originally a store demo unit. It has a clear plastic top panel so that you can look down and see the internals. And speaking of the internals, here's a photograph of the stock internals of the amplifier, and that amplifier board, that main board, is somewhat larger than the ones that were used a little bit later. That is called a PL0171 board, and we're going to talk about it later because that board, I think, is part of the reason these amplifiers got a bad rep for blowing up. So here's a close-up of the original filter caps, or one of them. It's a 9800 microfarad Sangamo capacitor, and while these caps were still in pretty fair shape, they were starting to show a little bit of leakage, and so they got replaced. Actually, almost everything in this amplifier got replaced. The customer wanted it rebuilt from the ground up, so that's what I did. We can see here a close-up of the original bypass capacitors for the filter caps. Now, large electrolytic capacitors can actually become inductive. They stop being capacitors and start becoming inductors at some very high frequency. And this is bad for the stability of an amplifier. So it's common practice to bypass the filter capacitors with some small film caps to stop that happening. And that's what these film caps are for. Here is a picture of one of the new Nichicon 15,000 microfarad filter caps. The originals were 9,800. These caps are exactly the same size as the originals, but due to improvements in capacitor technology over the past 50 years, you can put a bigger capacitor in the same physical space than you used to be able to. And here we see the new Dayton Audio bypass capacitors replacing the early ones. They do the same job. They're just new caps to replace the old caps. So here we see the White Oak Audio Driver Board. This is a brand new circuit board that will replace all the electronics inside the amplifier. It's called a PL14_20, and it's provided to you as a kit. You can have it built, but I decided I wanted to go ahead and build this one myself. Also, it makes things a little bit less expensive if you do it that way. So here we have a picture of the empty board, and this is a picture after the diodes and the small resistors have been put in. Then the larger resistors and the op-amp sockets. Then the film capacitors and mica capacitors. Now the small transistors and voltage regulators go in. Next go the larger transistors with their heat sinks and the bias potentiometers. Then the electrolytic capacitors. Then on the back of the board, there are 3 jumper wires with Teflon insulation that have to be added. Then comes screw terminals for wiring the board into the amplifier. This is a view of the top of the board as you would see it if you were to look down from the top of the amplifier with it installed. Here are the screw terminals that go on the back of the amplifier board for bias compensation transistors, and we're going to talk more about those transistors in a minute. Now, the old board, as you see here in place, is mounted with 4 mounting bolts, and here they are circled in red. The new board only has 2 mounting holes circled in red here, so I knew I would have to drill holes in the chassis to match. This was not necessary if you were refitting this board into a newer model 700, as their smaller main boards have the same mounting as this White Oak audio board. Now we go back to the old board, and you can see this is part of the reason that the amplifier got the nickname Flame Linear. There are two transistors on the old board here highlighted in red. These are the bias compensation transistors. Normally, these are mounted to the heat sinks so that they get hot when the output transistors get hot. They pick up the heat from the output transistors, and they turn the bias down in the amplifier, which causes the amplifier to run cooler. The problem is that when the PL0171 board was designed, they made a mistake, and these bias compensation transistors ended up mounted on the board instead of mounted to the heatsink. And mounted to the board, they cannot pick up the heat from the heatsink, and so they do no good. They do not compensate the bias for the heat of the output stage, so they're really doing no good at all. And this causes the amplifier to run hotter than it should. And I really believe that might have something to do with it earning the name Flame Linear early on. Later revisions of the amplifier had fixed this when they went to the smaller drive boards. But in this case, I knew I was going to have to do something to give the new board bias compensation transistors that were actually mounted to the heatsink. So I chose from my stock a pair of 2SC2690As, which you see in this photo. These are a little bit larger transistors, which have a hole in the case, and the case is completely insulated, making it possible to mount these directly to the heatsink, where they can pick up the heat from the output stage and do their job, compensate the bias. And here you can see that I mounted these to the back panel using two of the old mounting holes for the old circuit board. Directly below the new transistors, you can see the thermal safety switches that kill all power to the amplifier in case a serious overheating condition occurs. Here is an image of the new board mounted and wired into place. And here we can see the new wiring of the input jacks to match the wiring of the later PL700s, although the later ones only had one pair of input jacks. This one has two. A new 20 amp power switch was added where there was no power switch originally, as well as the blue capacitor you see, whose job is to suppress the arc that would occur inside the switch when the unit is turned off. Putting this capacitor across the switch will make the switch last a whole lot longer. The original meter lamps were replaced with LEDs, so I added this small DC power supply to run the LEDs without any chance of flickering and to make sure that they had enough voltage. At this point, after bringing the amp up slowly with a variac and a dim bulb tester, the bias current was set on both channels and the amp was played for the first time. Success! But wait! There's more. The old volume pots were then replaced, and at the client's request, an internal switch was added to allow the meters to swing with only a couple of watts output for when the amp was not playing loudly. On the right-hand side of this image, you can see the new speaker relay board I installed, made by a company called Watts Abundant, which gives the 700 the same speaker protection capabilities that modern amplifiers have. The circuitry on that board watches the output of the amplifier for any signs of direct current, and if it sees direct current, it immediately disconnects the speakers to protect them. It also provides a few seconds delay when the amplifier is powered up before connecting the speakers, and it disconnects the speakers instantly when the amp is powered down. The new board also replaces the old output stabilization circuitry, and it comes with new speaker terminals for the amplifier as well. At this point, the amp was tested once again, and then the last of the upgrades was begun. All the work done so far was done with the original output transistors in place. But now it was time for brand new output transistors and brand new insulators for both the outputs and the driver transistors. So the output transistors were replaced, the insulators under those transistors and under the drivers were replaced, the output stage was rebiased, and the amplifier was then ready to be buttoned up and fully tested. That's where this video stops, and that's where the next one will begin. So keep an eye out for part 2 of this video. Thanks a lot. Bye-bye.